Let's take a look at example 1.8. It says there are 2 boys and 5 girls in a group. How many different ways can they be arranged in a row if it does not matter who they stand next to and the boys do not stand next to each other? So we've got 2 boys and 5 girls. We've got 7 in all. So here's the solution for part A, pen and paper ready in hand. So all the students are different. So you have 7 distinct objects. So the total number of arrangements that you can make with all of them in a row is basically 7 factorial, which is 50, 40. And again, since you are arranging all 7, so that's 7 times 6 times 5 times 4 times 3 times 2 times 1, because you're arranging all 7 of them. No, part B, no. It says that the 2 boys do not stand next to each other. Okay, so therefore now, you have 2 different methods to apply this, to calculate this. Let's look at method number 1. It says one possible arrangement of boys not next to each other. That's one possibility. So it's always a good idea to draft out a possibility to get a feel of what you are doing. Because bear in mind, that's also reflecting a physical activity. You are calculating the total number of ways that this can be done. So one of the ways is like that. You've got a boy, a girl, a boy, a girl, a boy, and a girl, girl, girl. So therefore now, as you can see, the 2 boys are not next to each other. And it's 2 boys. So hence, why not calculating all the permutations where the boys are next to each other? So treat the boys as 1, group them up, then subtract the answer from the total. Calculating the number of permutations where the boys are together can be done 2 ways. So you could treat the boys together as 1 closed group, making n b plus g, make it equal to 6. So you've got 1, 2, 3, 4, 5, 6, because the 2 boys are treated as 1. Then you have 6 factorial as 720. That's all the permutations where the boys are next to each other. Now, with every arrangement in the 6, the 2 boys themselves can be arranged amongst themselves. So whilst you are arranging the 6, at the same time, or for each of, you are arranging the boys together amongst themselves. Okay, or you can say, and you are doing that also. So this is interpreted as multiplication. So that's 6 factorial and 2 factorial. That's 1,440. That's all the permutations where the boys are together. Now, arranging the boys and arranging the girls. That's another way to arrange where the boys are next to each other. So that's like 2 factorial times 5 factorial. Now, keeping the boys together, they can fit into the 6 available spaces within the girls, each forming more permutations for every one calculation calculated in the 2 factorial times 3 factorial. So thus you have 2 factorial times factorial times 6 factorial times 6, which is equal to 1440. So that's another way to calculate the boys next to each other. Let's take a second look at that. Here you have a situation whereby you have 5 girls, which created 6 spaces. So it says arranging the boys and arranging the girls. So that's 2 factorial times 5 factorial. So take, for example, in this space there, that space to the left, you are arranging the 2 boys and you are arranging the 5 girls. Okay, so that will give you 2 factorial times 5 factorial. And separately now, you can put the two boys in here, in that space there, and repeat the same thing, arranging the two boys and arranging the five girls. Now, this new set of arrangements, that 2 factorial times factor 5 factorial, going to give you 2 factorial times 5 factorial new permutations that would not the same as the 2 factorial times 5 factorial times 3 factorial when the two boys were in this space there on the left. And this can be done 6 times. So that's why you have times 6. 2 factorial times 5 factorial here, plus 2 factorial times 5 factorial here, plus 2 factorial times 5 factorial here, plus 2 factorial times 5 factorial here, and here, and here. Or you can say or here and or here. So that's 6 times, and that will do the same 1,440. So that's 2 different ways of calculating the total number of permutations when the boys are together. First, treat the two boys as one and permute them with the girls, making it like 6 factorial, and at the same time permuting them. So that's 6 factorial times 2 factorial. Or permute the boys in that position here whilst permuting the girls. Then do it here, repeat it here, repeat it here, repeat it here, repeat it here. That's 6 times. So you can either add all those 6 different activity or just multiply by 6. And then now what you do now, after you have calculated all the permutations when the boys are together, you subtract that from the total number of permutations, which is 50, 40. And that will give you the total number of permutations when the boys are not next to each other. Or you could apply method number 2. Since the boys are not to be consecutively next to each other, each must be sandwiched between the spaces between the two girls. As seen in the diagram, there are 6 spaces that the two boys can select from and have to arrange, and the 5 girls have to form arrangement. So 2 is selecting from 6, 2 boys selecting from 6 spaces, that 6 choose 2 times 2 factorial, where you are arranging the 2 boys, and at the same time you're going to arrange the 5 girls, and that will give you the answer directly, which is 3,600. Please do this using pen and paper. And you can also do your private search, permutations when objects are not next to each other, and you can get additional perspectives and more insight with that particular restriction. Take note that the method 1 applies very well when you have only 2 items that you want to separate, not being next to each other. But when you have more than 2, for example, 4, you cannot just simply calculate the total number of arrangements next to each other, which can be easily done, okay? Which can be easily done, and then subtracting from the total, because in the total, you've got possibilities like this when you have more than 2, which cannot be, which is not present when you have only 2. For example, in a situation like this, you have that happening in the total number of permutations, and this violates the restriction of they not being next to each other. Okay, they not being next to each other. That's what you want. Look what you want. That's what you want here. The bees must not be next to each other. They must not be consecutive. there must be at least one G separating the B's. That is what you want, okay? So you're simply subtracting together from all will not give you the correct answer, because in the all, in the total number of permutations, you have those they're happening, okay? Which violates the restriction of these not being next to each other. So therefore now you have to apply method number 2, which is this method, and it applies to any number that you want to group up and calculating not being next to each other.